What if your chat app could be encrypted unlike WhatsApp, but still smart enough to stop phishing, spam, and toxic content before it spreads? This is LockTalk, an AI augmented encrypted messaging research prototype. It uses X25519 key exchange, AES256 GCM encryption, and ED25519 digital signatures to guarantee confidentiality, integrity, and authenticity. But here's a small twist. Before encryption, an AI guard scans the message in real time to detect threats. So, the real question is, can privacy and AI safely coexist? Let's find it out. Hello guys, welcome to next project demo by Project Maker. In this video, I would be demonstrating my new project which is of LockTalk, which is an AI augmented encrypting messaging prototype. So before explaining you the background architecture and technical terms that I use in this project, let's see the project demo first. So I will simply click on this authenticate button to simply do login. For now, let's create a new user. And as you can see, it's asking me to enter few details. So let's say I will add Brett Adams, and the next is unique user ID, and I will just add a strong password. And as you can see, I have written the password. Now I will simply click on this generate key pairs. So as you can see, this is the chatting application which is open in front of you. Now let's create another user so that we can do basic chatting. So I will simply open the same application in incognito mode. So as you can see, this is the incognito mode, and I will type the same URL which is this, as you can see, and I will simply go to authenticate, register another user, and I will simply type name as Matt Pons, and let's say user ID will be underscore 007, and I will simply write strong password for this also. As you can see, I have added the display name as Matt Pons, unique user ID is Matt007, and the password, and I will simply click generate key pairs. So as you can see here, I am logging as Matt Pons, and this is the user. If I simply click on this chat and hit hi Brett, which is just a plain message and it is not spam message or not a phishing type of message. And if I simply hit enter, and as you can see, the message is successfully delivered from Matt Pons to Brett Adams. And now let's check the Brett Adams side. So as you can see, this is Brett Adams, and if I just hit enter, so as you can see, the message is received which is hi Brett. Now let's try some spamming or phishing message. I have already collected a sample spam message from internet, which is this. Congratulations, you have won a 1000 Walmart. Click here to redeem. And if I simply hit enter, the message will be sent as a normal message and Brett would not know anything about it. But on receiver side, let's see what is happening. And as you can see on the receiver side, the same message has appeared as yellow, alerting user that this is a spam message, so please be alert and don't click any link. This will help the user to get alerted in advance, and if such type of message comes from unknown person, he will never click on the link. Now let's try to detect some toxic messages like this. So as you can see, the message that I type looks toxic. So I will simply hit enter, and the message is simply sent to Brett Adams. And if I see the Brett Adams side, and as you can see, it's now appearing in red format because this is a toxic message, and this message can simply make Brett uncomfortable or emotionally unstable. Also, I would like to let you know that if a person using this chat application continues to send such type of messages, then that account will get automatically deleted from the app, which ensures that the accounts trying to spread spam messages or spreading toxic content would be banned from this app. This simply ensures the user safety, privacy, and confidentiality. And also, I would like to show that the inspector part of thing, which is most important. This will simply help you to see how the messages get encrypted. And as you can see, this is the message sent. Congratulations, you won 1000 Walmart gift card, which was this message. And this is the cybertext which is encrypted. You can see the same cybertext on receiver send too. So let's test that. So this was the spam message. If I simply go to Encryption, it's currently showing for this. But if I click this, it will show the same cybertext which is D703 and ends with 4020, and which is the same D703 and ends with 4020. So this proves that instead of sending original message, this ciphertext is sent over internet to the receiver. After receiving the ciphertext, the real-time decryption happens on receiver send and the message is displayed on the chat application. In the similar way, you can see the cybertext for any of the message. If I see, let's say, hi Brett. So this is the cybertext, and for this is the cybertext. So this was the main idea of my entire project, where I focused on maintaining privacy, confidentiality, and integrity of the users using this platform. Now, without wasting any time, let's directly jump into understanding the technical details and background architecture that I have used to create this application. So I will simply click on the disconnect button. It will come to login screen again, and let's simply start from scratch. So as you can see, this is the overview or the homepage of this application, which says next generation secure communication. Here I have clearly mentioned that LockTalk replaces vulnerable centralized messaging with purely distributed, mathematically proven cryptographic architecture, which clearly means that your data never leaves your device unencrypted. Now let's scroll down, which is server blindness, local key vault, and instant web sockets. So let's talk about first server blindness. The server only routes the encrypted data packets and has zero capability to read or decrypt the message, ensuring true zero knowledge message delivery. The next is local key vault. In this, your private keys are generated and stored secured inside your browser, meaning they never leave your device or travel across networks. And the last one is instant WebSocket. LockTalk uses persistent WebSocket connection to deliver message instantly while preserving the integrity of cryptographic handshake and processes. The next is the core message protocol stack. The first one is message encryption, which is AES 256 GCM. Every message you send using this application, which provides both strong encryption and built-in protection against message tampering. And I use X22519 key exchange, which securely generates shared secrets between users while enabling perfect forward secrecy for stronger long-term protection. The next is digital signature, and I use ED25519, which ensures every message can be mathematically verified to confirm the sender's identity. The next one is RSA2048. RSA2048 establishes long-term identity keys that securely wrap and exchange encryption key between users. And the last one is threat detection, which is an SQL model created using random forest. And it is a client-side AI model that evaluates incoming messages in real time to detect phishing, spam, and malicious pattern. So this was the basic overview of the LockTalk. Now let's simply move to the architecture of it. And as you can see, I have tried to create a simple, beautiful user interface which tells the main architecture of the project, which is from client A Alice to client B, and in middle Flask WebSocket are work like blind routers just to deliver the encrypted message to the client. And let's move ahead. And here comes the multi-layer protocols. And the first protocol is AES-256 symmetric encryption. In this, each message is encrypted using one time 256 byte key, ensuring that identical messages produce completely different ciphertext. The next is RSA OAEP key wrapping. This is temporary encryption key used for the message security wrap using the recipient's RSA public key. Coming forward, which is ED25519 signature. As told earlier, every message is digitally signed by the sender, allowing the receiver to verify that the message truly came from the claim identity. And the next is perfect forward secrecy. So this concept ensures that even if the identity keys are captured in the future, previously captured encrypted message remain impossible to decrypt. And the last part is local storage poster. The central database stores only encrypted data while message decryption and key storage happens locally on user's device. This ensures that user keys and user signatures are completely safe and doing their job perfectly. And the next most important part is PBKDF2 key protection. So the password that you write by registering, it is strongly protected using this technique, which is PBKDF2 HMAC SHA256, protecting your vault even if the device is stolen. So the end goal of all this multi-layer protocol is to ensure every message is encrypted with military graded AES-256 encryption and protected against tampering. So now let's move to the next slide, which is blueprint. In this page, I have simply added the system architecture and EI diagram of this project. So simply let's understand, which says that our architecture is split into three distinct layers to ensure maximum isolation of sensitive data. The client layer handles all the encryption, meaning plain text never leaves your device. So this is the client layer. As you can see, this is the server layer and this is the persistent SQLite layer. Client layer handles chat logic, socket IO, and key side management. The server layer simply manages the backend part, the ML phishing detect toxicity filter, and Python cryptographic engine. And the server side simply manages the key storage and system database where all the messages and user details are stored. So this is the system architecture of this LockTalk project. Let's move ahead to understand the next, which is web portal. This web portal simply says that the encryption simply happens on the browser itself or sending the message to the receiver. The next part is blind router, which I already discussed. The job of this blind server is simply to pass the encrypted message from sender to receiver. And the last but most important part is AI Guardian. It is an integrated ML pipeline that analyzes messages for spam and phishing locally on server during the routing process. And the next is data persistent ER diagram, which is entity relationship diagram. And I would like to let you know that the database is designed with privacy first principle. So as you can see, there are three tables: users, messages, and one-time keys. And everything is managed between these tables. And you can also see the connection between this table, which is primary key, foreign key, and so on. After that, the vault isolation, which simply says that the message that you received or that you send stores in your local device as encrypted message and not a plain text. And the next is forward secrecy. This ensures that even if your long-term key is compromised, your old conversation stays secured. And I have already discussed this earlier. Now let's move to the last part, which is platform. The platform engineering trust. LockTalk was engineered to solve fundamental flaw in modern communications, the reliance and central authorities to handle encryption keys. By shifting cryptographic burdens entirely on edge, we run data sovereignty to user. And the AI Guardian subsystem. And as I told, it can classify phishing and spam messages. And I have already demonstrated this to you. And the last part is technology stack. So backend routing is done using Python 3.11 and fast web server. Real-time sync is done using Flash Socket IO, and analytics engine are SQL pipeline converting text to identify the spam and phishing messages and raising alert. And this model is trained using a random forest classifier model. So this was all about my entire LockTalk project. I hope you enjoyed this project demonstration, and I hope you have enjoyed this project and understood all the technical terms and the architecture that I tried to explain you. But if you have some doubts or have not understood any concept related to this project, then please do ask me in the comment section below, or you can message me on Instagram to clarify your doubts. So that's all for this video. If you like this video, then don't forget to share this video with your friends and family members. Here comes the end of this video. Thanks for watching this video.